point in a three-dimensional space. In this module, you will learn to locate a point in a three-dimensional space. A point in xy plane can be represented by its x and y coordinates. But how do we determine the position of a point in a three-dimensional space? A minimum of 3 coordinates are required to represent the position of a point Q in space, and generally it is represented by x, y and z coordinates. The perpendicular distance of a point from yz plane is called its x coordinate. The perpendicular distance of a point from xz plane is called its y coordinate, and the perpendicular distance of a point from xy plane is called its z coordinate. The x and y coordinates of point Q can be determined by dropping a perpendicular from Q on the xy plane and then drawing two perpendiculars from point R intersecting OX and OY at points S and T respectively. The distances OS, OT and QR represent the x, y and z coordinates of point Q. The previous discussion helps us to generalize that the distance of a point along the x-axis is called as x-coordinate, the distance along the y-axis is known as y-coordinate, and the distance along the z-axis represents z-coordinate of a point in the three-dimensional space. Notice that x-coordinate always comes first, y-coordinate comes second, and z-coordinate comes third. Conversely, if you are required to locate a triplet x, y, z in three-dimensional plane, first locate a point whose coordinates are x, y in the xy plane. Then drop a perpendicular of length z onto this point. The point P represents the point with coordinates x, y, z. Since the origin is at the intersection of these three axes, and the distance of the origin is equal to 0 from all the axes, its coordinates are 0, 0, 0. Also, a point on x-axis has its y and z coordinates 0, as the distance of the point along OY and OZ is 0. Similarly, a point lies on y-axis if its x and z coordinates are 0, and a point lies on z-axis if its x and y coordinates are 0. The sign of the coordinates of a point help us to determine the octant in which the point lies. Since the first octant contains positive x, y and z axis, all the coordinates of the points in this octant are positive. Similarly, second octant consists of negative x-axis and positive y and z-axis. So, the x-coordinate of the points lying in this octant is negative, whereas y and z coordinates are positive. Further, the third octant consists of negative x and y axis and positive z axis. So the x and y coordinates of the points lying in this octant are negative, whereas the z coordinate is positive. Next, the fourth octant consists of positive x and z axis and negative y axis. So, the x and z coordinates of the points lying in this octant are positive, whereas the y coordinate is negative. Similarly, in fifth octant, all coordinates of a point are positive except z coordinate. In sixth octant, all coordinates of a point are negative except y coordinate. In seventh octant, all coordinates of a point are negative. And finally, in eighth octant, all coordinates of a point are negative except x coordinate. Let's summarize what you have learned in this module. The coordinates of a point in three-dimensional geometry are always represented in the form of triplet like x, y, z, where x, y, and z are distances from the yz, zx, and xy planes, respectively. X, y, and z axes intersect each other at a point called origin, whose coordinates are 0, 0, 0. The y and z coordinates of any point lying on x-axis are 0. The x and z coordinates of any point lying on y-axis are 0. The x and y coordinates of any point lying on z-axis are 0. The signs of the coordinates of a point help us to determine the octant in which the point lies.